students. Today we will see fundamentals of advanced biology techniques part 1. We will see there are 6 different techniques: real-time PCR, multicolor flow cytometry, mass spectroscopy, circular dicroism, electrophoresis, protein DNA interaction, fluorescence, resonance, energy transfer, FRET. Today we will discuss about circular dicroism. So this is the instrument with which you can perform circular dichrometry. So what is first of all circularly polarized light? So in figure we can see there are 3 things given. First is unpolarized light, where the light waves move in all direction. Second is linearly or plane polarized light, where it is passing from one plane to the other. The third type of polarization is either it can be left-handed polarized or right-handed polarized. This is known as circularly polarized. Now, how can we calculate circular dichroism? So, one is by difference method, that is using Beer-Lambert's law, and another is by measurement of ellipticity of the light. First method is difference method. So, the light is polarized either left-handed or right-handed. When it is passing through sample, optically active molecules will absorb it, and left-handed and right-handed light will be differently polarized. So the difference in the absorbance is called circular dichroism or CD. Now how to calculate? So you can take the difference in the absorbance, that is absorbance of left side minus absorbance of right side. So delta A is AL minus AR. According to Beer-Lambert's law, A is epsilon into C into L. L is length of cell, C is concentration. And so delta A is difference, that is EL epsilon L C into L minus epsilon R C into L. So ultimately we will get as delta epsilon is equal to delta A is equal to circular dichroism. This is net absorption. Second method is ellipticity method. So when the light is passed, when polarized light is passed through the sample, optically active molecules will absorb. Now here interesting thing is you can see that the red circle is small and the blue circle is large. So blue circle represents right-handed side polarized light and red circle represents left-handed polarized light. So we can say that the sample absorbs more amount of left polarized light than right polarized light. So we will have an angle. That angle is related to difference in the absorbance. Delta A is theta upon 32.982. So delta epsilon is theta divided by 3298.2. Applications, this is a very simple method and it gives us information about secondary structure of protein. We can also check the effect of different environmental factors onto it. How it is better in terms of XRD and NMR is that it requires very small amount of sample like microgram, but it is less informative than above two methods obviously. How we can do that? So this is our standard spectrum. We have to remember this because all of the interpretation for determination of secondary structure of the protein is based on this curve. So as we can see, one positive and two negative bands, one positive at 190 nanometer and two negative at 220 and 208 nanometer is indicative of presence of alpha helix in the structure. If beta sheet is present, then it will give a negative band at 218 nanometer and one positive band at 196 nanometer. If it's a random coil, then you will have a positive band, you will have starting from negative band or negative point, say around 195, and one positive band at 212, which is quite broad than these two. Right now, let us consider the interpretation. Like these are different proteins: chymoproteins, lysozymes, then trienophosphate isomerase and myoglobin. So as we can see, chymotrypsin, this blue line, so it is very much similar to our beta sheet. So it is all beta structure, lysozyme and so on. Now you can also determine the effect of different environmental factors like temperature. So as we all know that it is a fact that proteins are denatured at high temperature. So that can also be studied using this. Like initially you can see here the protein is having more amount of alpha helix, right? As the temperature is increased up to 50 degrees, the alpha character is reduced and it becomes similar to beta character, and as you go on heating at 75 degrees centigrade, it almost is converted into a random coil structure. This is how you can use circular dichroism. Thank you. If you have any questions, I'll be happy to answer.